Hello, good morning. This is for the lecture Sustainable Product for Concrete. This is the topic 4.3 and the learning outcomes is as stated in the slide. Okay, we move on to the fiber reinforced plastic, or we also known as FRP, and composites. Okay, for fiber reinforced plastic, or FRP, is a composite material made of polymer matrix reinforced with fiber, for example glass, carbon or aramid materials, to mechanically enhance the strength and elasticity of plastic. So basically this is polymer, but this polymer is reinforced by fiber. So FRP are commonly used in aerospace, automotive, marine and construction industry. What are the advantages for FRP and composite? Basically, we use FRP because FRP is lightweight. Even though it's light, it have a very high strength, extreme durability, stability under UV exposure and chemical resistance, can be molded into an infinite number of form and surface finishes, and also capable of meeting stringent design standard while at the same time providing major cost benefit. Okay, meaning that in terms of flexibility, FRP is more flexible to compare with other materials such as concrete and steel. And we also know that fiber reinforced composite typically contain one or more reinforcing fiber materials embedded in plastic resins. In many applications, core materials are used to increase the section modulus. And for fiber reinforcement contribute the bulk of strength and stiffness to a composite. Okay, because of fiber is the component that reinforce the polymer. Okay, for characteristic and limitation of resins, okay, this is what you can see in a table. Okay, for resin type polyester, the characteristic is wide choice of resin, cure at room temperature, very good mechanical properties, good chemical resistance, good electrical properties, and the limitation is some shrinkage on curing. So you have another more resins, for example vinyl ester and also epoxy. So right now we have a lot of material used epoxy because of it is very easy to work with epoxy, and in terms of aesthetic, epoxy also is an excellent material to be used. Okay, this is a mechanical of FRP versus other structural materials. So you can see we compare with aluminium, concrete, mild steel, stainless steel and also FRP. And we compare in terms of specific gravity, elastic modulus, tensile strength and compressive strength. Okay, if we look into specific gravity, most of the material is more than 2.3 in terms of its specific gravity, meaning that the density is very high. So you can see it is logic for mild steel and stainless steel have the specific gravity of 7.8 and 7.9. If you can see FRP is only 1.5 to 2.2, is very light. So in terms of elastic modulus, it has been stated here in the table. We do have the tensile strength, okay, meaning that FRP can achieve up to 900 tensile strength. So it's very resistant to tensile. And for compressive strength, it is about 130 to 550, and for concrete up to 100 megapascal. But the rest of the material is very weak in terms of compressive strength. We also know about aluminium, mild steel and stainless steel is not have the quality to give the compressive strength, but it's very good in terms of tensile strength. So FRP have both quality. It can resist, it can give a very good in terms of tensile strength and also compressive strength. So these are the types of fiber reinforced plastic. Okay, types of fibers are glass fiber, carbon fiber or aramid fiber. Types of polymer, epoxy, vinyl ester or polyester thermosetting plastic. So you can see this is glass fiber is mostly widely used reinforcement in the FRP composite industry. It is the glass fiber. In industry, it is often referred to a glass reinforced plastic. Glass reinforced plastic is lightweight and has good thermal insulation properties. It has a high strength to weight ratio, making it useful for the production of products such as water tanks, surfboard canoes, small boat hull, and similar products. So this is another example for common glass fiber form. We have chopped strand mat, woven roving, continuous filament mat, woven glass cloths, and glass flakes. For carbon fiber, this is a carbon fiber. You look at the picture. This is the look of carbon fiber. Carbon fiber reinforced polymer or carbon fiber reinforced plastic, CFRP or CRP, are often simply carbon fiber. Is a very strong and light fiber reinforced polymer which contain carbon fibers. The polymer is most often epoxy, but other polymers such as polyester, vinyl ester or nylon are sometimes used. The composite may contain other fibers such as Kevlar, aluminium, glass fiber as well as carbon fiber. So we have endless option to use in construction material provided you have the allocations of money or not and the specification given by the clients. So we also have the aramid fiber. Aramid fiber are most commonly known Kevlar, Nomex and Technora. Kevlar fiber were originally developed as a replacement of steel in automotive tires. Distinctive feature of Kevlar are high impact resistance and low density. So we can have all of these properties listed in the slides, including low weight, high chemical inertness, very low coefficient of thermal expansion, and textile processability. Is more like textile, so it is have the flexibility to work with, and you can read the rest of the properties inside the slide. So application of FRP, reinforcement bar for concrete. It is pre-stressing tendons for concrete members. FRP sheet can be used to increase flexural strength in weakened or under design members. It looks like a mat, and what this construction worker do is to attach to the reinforcement bar or for concrete, so it gives more in terms of strength, both tensile and compressive strength. Advantage and disadvantage of FRP. For the advantage, it will not corrode in field condition. It is lightweight, strong in tension, method of construction same as steel reinforcement. The advantages is low modulus of elasticity. It cannot be shaped in the field. More expensive than steel. Coefficient of thermal expansion are different than those of steel or concrete. Okay, these are the fiber reinforced concrete. It is look like fiber. What we do is we put the fiber inside the concrete mass. So you get a lot of example of fiber reinforced concrete using this type of material. For fiber reinforced concrete, FRC is concrete containing fibrous material which increases its structural integrity. It contains short discrete fiber that are uniformly distributed and randomly oriented. Fiber includes steel fiber, glass fiber, synthetic fiber, and natural fiber. So you can use whatever possible for reinforce the concrete, to reinforce the concrete. Effect of fiber in concrete: it control cracking due to both plastic shrinkage and drying shrinkage, reduce the permeability of concrete, reduce bleeding of water. Some types of fiber produce greater impact, abrasion, and shatter resistance in concrete. Indeed, some fiber actually reduce the strength of concrete. So this is a glass fiber. It is made from extremely fine fiber of glass, effectively replace asbestos in many applications such as in electrical, thermal and acoustic installation, and in adding structural reinforcement and heat resistant to a material. So this is quite a common material that you can use. It very flexible. You can actually build a boat using glass fiber. And a lot of material you can use from glass fiber to make another material. Right, now we are looking to the advantage and disadvantages of glass fiber. For advantage, it's very high tensile strength, excellent resistance to sunlight, very brittle, cheaper, does not burn, good dimensional stability, resistant to mildew, rotting and insect, zero moisture absorbance. The disadvantages is adhesion difficulties, relatively heavy. Glass fiber is breathed into the lung, can promote fatal cancerous growth, brittle, poor flexing properties. Okay, this is steel fiber. Steel fiber is a kind of newly developed reinforcement for concrete widely adopted globally nowadays. Compared with those using common concrete, the project using steel fiber are increased evidently in anti-stretching, anti-pressing, anti-abrasion, anti-cracking, and anti-bending. In a steel fiber, the fiber spread the strain across the crack created in matrix. In other terms, the fiber are only useful if there are potential cracks in the material. Steel fiber concrete has already been used for and wide onto many fields such as road, bridge, airport, runways, tunnel, covered, and so on. So you can look the cast concrete with steel fiber, and we can already see the steel fiber inside the concrete. Okay, function of using steel fiber in concrete to prevent crack, and also it is for ductility. And of course it will give more in terms of tensile stress and also energy absorption. Okay, these are the advantages of steel fibers: resistant to impact, blast and shock loads and high fatigue, shrinkage control of concrete, very high flexural shear and tensile strength, resistant to spitting, spalling, erosion and abrasion, high thermal temperature resistant, resistant to seismic hazard. Meaning that your original concrete cannot behave like this one, but if you add steel fiber inside the concrete mix, you will have all of these kind of properties, and the properties has been enhanced. So this is a natural fiber. We use coconut fiber. What you do is you mix the concrete and put the coconut fiber inside the concrete. So coconut fiber is extracted from the outer shell of a coconut. Two types of coconut fiber: brown fiber extracted from matured coconut, white fiber extracted from immature coconut. For coconut fiber are commercially available in three forms: bristle, long fiber, mattress, relatively short, decorticated mixed fiber. So we don't really alienated with this coconut fiber because we are living in Malaysia, a lot of coconut, so you can use coconut fiber as the mix in concrete. In engineering, brown fiber are mostly used. COF provide a natural non-toxic replacement for asbestos in the production of cement fiber board. The fiber reinforced concrete is strong, flexible and may be less expensive to produce than other reinforcement methods such as wire mesh or rebar. Because this is natural, we already know the texture is quite natural and very good in terms of the production. So advantages, it is resistant to fungi and rot, provide excellent insulation against temperature, not easily combustible, flame retardant, unaffected by moisture and dampness, and so much more. And this is another thing that you already know in our construction. We have this kind of system, what we call is industrialized building system. The IBS is a construction process that utilizes technique, product, components or building system which involve prefabricated component and on-site installation. So IBS, basically you need a factory so that you can produce a lot of IBS product, and then you use this IBS to be transported to the site and when you get to the site, you just install the IBS product. So what are the IBS? We have precast concrete framing, panel and box system, steel formwork system, steel framing system, prefabricated timber framing system, and blockwork system. So these are the kind of IBS products. This is very good in terms of to speed up your construction time. And what you do is you cast all this material in the factory, then you need to arrange the transport, and then you bring it to the site and to install it to the site. The advantage of IBS, the reduction of unskilled workers, less wastage, less volume of building material, increased environmental and construction site cleanliness and better quality control among others, promote a safer and more organized construction site, reduce the completion time of construction. Many world-class Malaysian developer has chosen IBS method for important projects such as Petronas Tin Tower, Putrajaya, KL Central and KLIA. So these are all the construction that already finished, and we already use it in our daily usage as Petronas Tin Tower, Putrajaya, KLIA and KL Central. And another one that you need to know is the green and recycled material. This is a green building material offers specific benefit. Promote conservation of dwindling non-renewable resources, reduce maintenance and replacement costs over the life of the building, energy conservation, improve occupant health and productivity, reduce the environmental impact associated with the extraction, processing, fabricated installation, and disposal of source material. So what are the green concrete? The green concrete include recycled demolition waste aggregate, fresh local aggregate, blast furnace slag, recycled concrete material. This is also example, manufactured sand for concrete, recycled glass aggregate, blast furnace slag, and fly ash. These are green concrete to be used, but this one is specifically for aggregates. Okay, for recycled concrete, meaning that old building that you crush and you use the material as your construction material. For this one, it is the most important construction material. Approximately 1 ton of concrete is used per capita per year throughout the world. Thus, recycling of concrete as a new source of cost aggregate can reduce cost aggregate, disposal cost, environmental damage, consumption of natural resource, and also landfill space. So this is another types of recycled material, but this is the recycled bricks. Okay, what we use crushed brick are the bulk of demolition waste which were earlier being dumped in landfill, but now they can be recycled into building blocks. It can also be used as construction infill or as aggregate for non-structural concrete. So this is a good material that you can use as the replacement with the already material that already available in the market. This is for recycled plastic. This is quite common and quite famous nowadays. We are using a lot of plastic in many of our daily consumption. So a lot of waste plastic available. So use this plastic as a recycled plastic. Waste plastic can be shredded and used as filler in concrete and construction of road. It is also can be used by household plastic waste and can also be recycled to obtain artificial lightweight aggregates for mortar. It can be used as recycled plastic, reduce the possibility of cracking. So that is all for this last chapter for this topic, and thank you.